Although not my fault. Apologies for that hiccup. Hiccup, like hiccup. No school, please. Jonathan, that's as good as I can get it, dude. I'm sorry if it's still laggy. Blame the school Wi-Fi. Write a letter. Tell them that we need better Wi-Fi. Okay, so we're done with our computers, yeah? So let's put them away because we just need our Algebra Nation book for now, please. So back to what I was saying. 9 to the 1/2 power is equal to 3. Just sit with that for a second. 8 to the 1/3 power is 2. Yeah. Oh my gosh. So Bryce is a genius. Okay. How did we get 3? How did we get 2? If you have an idea, if you have anything to say about that, let me know. Okay, Thorn, what do you think?
Don't you?
Oh, sorry. Hold on, Jonathan. I'll come to you after Thorn.
It doesn't make much sense.
Okay.
It does kind of make sense.
Okay.
But so like, you know how like 1/2, 1 and 2, if you add them together, you get 3, and then if you divide it up and if you divide 9 by 3, you get 3. Same with 8.
Okay, that just happens to be coincidence for these two, but that is a great thought. Jonathan, go ahead. You're gonna say something.
Don't you take the 9 and split it into because with the 8 there's the 1/3, so don't you cut the 8, or don't you divide the 8 by 3, and for the 9 don't you divide the 9 by 2?
Okay, so if we did that, it would be 4.5, and I don't know what 8 divided by 3 on the top of my head is, like 2, yeah, something like that. Renee, were you gonna say something? And then I'll come to you, Esteban.
I think it's kind of like reversed.
Okay.
Because if you do it like on paper, it would kind of be like you could put it in like an equation with like 9/1 and then like that, and then like times or divided by 1/2.
Okay.
I think it's division, because if you do the multiplication, you would get like the same thing what Jonathan said, just in like a longer form.
Okay.
But I'm not sure. I think that.
Okay. Esteban.
I have a theory, and it kind of makes sense. 2 plus 1 is 3 divided by 9. 3. You already said that.
Yeah. Thor already said that. Madison. Yes. Oh my gosh, Madison. Yes. So Madison goes, sorry if I yelled at you guys, my bad. Is the fraction whatever the root is? And that is a yes. So for the 9, since the fraction is 1/2, we're taking the square root. The square root of 9 is 3. For the 8 to the 1/3 would be the third root. And when we're talking about third root, we're talking about what number times itself 3 times is going to give me that number. So 2, I'll show you the list in a second. Hold on, let me finish. So what number times itself 3 times would give us 8? 2 times 2 times 2. So the answer to that would be 2. So these are the same as their roots. And if you don't have your roots memorized, which I would assume you probably don't, I gave you a list in your OneNote. If my OneNote wants to open or not. Oops. Under reference pages, there is a list of all of the squares, cubes, fourths, and fifths here. And what I can do is I can look up. So if we were talking about to the 1/3 power, you'll notice that 8 is right here. And if we go all the way to the first column, the third root of 8 is 2. Yeah. If we were talking about the third root of 216, I would go to 216 and I look all the way to the first column. and it would be 6. You are allowed to use this at any time you would like to. You don't need it right now, but because I'm going to pull it up whenever we need it. But anytime you need to look at those squareds, thirds, fourths, fifths, they're there. Most likely we're going to stay under the squareds column. We won't a whole lot of the time go under the third, fourth, and fifth columns, but I'll just let you know that. If you didn't know the third root of 8 is equal to 2, you can also use your calculator. So let me explain how you would do that. Especially if you have this calculator, okay? So on this calculator, to find the third root, you're gonna type in the number you're trying to find. So that number is 8, okay? Then you're gonna hit the shift key, which is in the top left-hand corner. And then you're going to hit the third button down on the left-hand side, which says like plus / minus. When you hit that, it should give you a 2 as the answer. So I'll repeat that again, because if you look right above that one plus / minus, you'll see that there's a third root, like written in yellow, like right above that. So again, if you're trying to find the third root of anything, you type that number first and then hit shift and then hit that button, you should get a 2. Okay. So we want to try and rewrite these things that have fractions using radicals. Remember, radicals are those root, the little check mark root symbol. So let's first look at this one, 2 to the 2/3 power. So I want everybody to draw a radical. Draw a radical. The big 2, the base number, is going to go inside that radical. 2. The denominator of your fraction is going to be which root you're taking. So in this case, we're taking a third root. So we're going to put a little baby 3 right outside that root. Now, what the heck do I do with that other 2? It is an exponent. 2 to the 2nd power. Now, why did we not do that on the other 2 problems? Everybody look at the numerator of the fraction of the other 2. Yeah, they were just a 1. So raising something to the 1st power is not going to change its value. So we don't really need it. Now, I would prefer you not leaving it like this because we can simplify it a little bit more. 2 squared is 4. So that would read the cube root or the third root of 4. These are the same thing. All we did was we rewrote the one with the fraction exponent into a radical. Radical. So let's look at the second one. 5 to the 3/2. So we want to draw our radical. We want to put our base, our big number, inside the radical, 5. What root are we taking? 2. Is it necessary to write the 2? No, not really. Because if there's no index or no little number, we assume that that number is a 2. Now, for our purposes, for now, I'm just going to write it. But if there were no number there, we just assume that it's a 2. And what exponent am I going to raise that 5 to? The third, because that is the top number in our fraction. And let's go ahead and do that. 5 to the 3rd power means 5 times 5 times 5, which is 125. Big brain. Okay, so let's make like a general statement. If we have something raised to a fraction, we can rewrite that something under the radical and make the denominator the root and the numerator the exponent. I'm holding. I'm still on the same page. I'm just going to rewrite. You may also see this as the root and the number in the radical inside parentheses and the exponent on the outside of the parentheses. They just mean the same. They're the two different ways to write the same value. I usually would write the first way, but it's not weird to also write the second way.
I mean,
Good so far?
Yeah.
Okay. So let's practice just rewriting some stuff from radical to exponent. So we've gone exponent to radical. Let's write from radical to exponent. So I have the square root of x plus 2. So I'm going to write parentheses x plus 2. And instead of writing a square root, I want to write an exponent. So how could I write the square root as an exponent? Well, I need a fraction. The denominator is, what root am I taking? Square root is what number? 2. So that's the denominator. And what exponent is x plus 2 being raised to? The first, right? Since there is no exponent, our numerator is going to be a 1. So on B, we're going to rewrite x minus 5. Does the 2 go in parentheses? It doesn't. Why not?
Because it's outside of the.
Yeah, it's not under the radical. It's kind of outside of the radical. So we're going to write it by itself. And what exponent do we want to write the x minus 5 to? Not 3.
2, 1.
It's going to be a fraction.
Yeah, wouldn't it be
1/3. The bottom number 3 comes from the third root. The 1 comes from the exponent. If there is no exponent, we're going to write what number? 1. Okay, so now we're going to go backwards again. So 9 to the 1/2 is the same thing as the square root of 9. And we know what that is. 3. 16 to the 1/2 is the same thing as the square root of 16, which is 4. Eight to the 1/3 is the same thing as the third root of 8, which we talked about already, is 2. Now let's talk about this next one. It's not 8 to the 1/3, it's 8 to the 2/3. So first let's rewrite it. It's still an 8, and we're still taking a third root. What do we need to do with that 2? Go ahead, Zion. You're fine. Yeah, we're gonna make it an exponent. So let's try and simplify. The third root of what is 8 squared?
64.
64. And I want you to take a second, see if you can figure out what the third root of 64 is, meaning what number times itself 3 times gives you 64.
4.
No.
4 times 4 times 4.
It is 4. Again, if you needed to use your calculator, cool, I'm cool with that. Or you could just know your third roots. It's totally up to you. This one you might want to use a calculator. 125 to the 2/3 power. So we want to write our 125 in our radical. We have a 3 outside that radical. And what exponent are we going to raise the 125 to? 2. So that's going to be a pretty big number. 125 squared means 125 times 125, which is 15,625. And then we want to take the third root of that.
Oh.
Hence why I asked you to use a calculator.
I know.
Yes, Kylie, that's right. It is 25.
Yeah.
Woo!
Move. Yeah.
Okay, let's try this last one together and then I'll have y'all do a couple on your own. So we have 16 to the 3/4 power. So we want to rewrite that as 16 and then the 4th root, and then the 16 is to the 3rd, which is 4,096. Now, if you're using this, Renee, make sure you're doing the cube root and not the square root. The square root of that number is 125, but not the cube root. Those are two different things. That's a great question. The 4th root, how do you do a 4th root? You can't. So let me show you how I would do this. So if you have this calculator, there's no 4th root button, okay? So what I would do is, because you're gonna have access to this at any time, I would go to this list and I'm looking under the 4, which is this column, and I'm trying to find 4,096, which is right there. If I jump to the first column, it would be 8, okay? So 8 would be the 4th root of 4,096, okay? All right, so I'm gonna give you some time and I would like you to do the try it. Number 3 on the try it, you're just changing them to rational, like the fraction exponents. 4, 5, or 4, A, B, and C, you're actually getting that one number answer, okay? Digital students, y'all send me your answer to A, B, and C when you're done. Okay, so the square root of y is the same thing as y to the 1/2 power. Remember, square root and 1/2 are the same thing. For part B, you should have had y plus 6 in parentheses to the 1/5 power, and then minus 3 would be outside the parentheses. Letter A, 49 to the 1/2 is the same thing as the square root of 49, which is a perfect square. It's 7. 27 to the 1/3 power is the 3rd root of 27, which what number times itself 3 times gives you 27? 3. And then number C, letter C, would be the 3rd root of 216 squared. 216 squared is 26. No, that's not right. Is that right? 2626? No, 46656. Which is a large number, but when you take the 3rd root of it, you should have gotten 36.
Yeah.
36. Beautiful.
I got that the second time, the first time I did 216 times 1, 2.
That's awesome. Let's look at beat the test. And then we will take, I will be honest, we probably won't be able to take our regular 10-minute break, but we'll have like a 5-minute brain break after this beat the test question, okay? So we're matching all the things in that first column with all the things in the right column. So if we look at the first one, 2 to the 1/3 power, we could rewrite as the cube root of 2. Do you see that in the second column? Which one? VI. Does anybody know what VI is in Roman numerals? 6. Yeah, Jonathan, 6. Do y'all learn Roman numerals? Is that a thing you learn? No? Okay.
I know all of them, like 10 is X.
Yeah, 10 is X. The only like place that I know like in real life that uses them is like when they talk about the Super Bowl numbers. Like that's the only time that I've ever seen like Roman numerals actually in real life be used.
I just know
Oh,
that-
music. You use them in music?
I've never seen them in music.
Oh, Renee said she learned them in music class in 5th grade. Oh, there's sometimes watches will have them too. Like fancy watches will have Roman numerals.
Yeah, like, in my fancy talk my mom has in her bathroom.
Yeah, or like grandfather clocks sometimes have them too. Not, I don't mean like y'all know what a grandfather clock is. Yeah, like not like your grandfather's clock, like a grandfather clock. Okay. So m minus 3 square root, we want to change that whole thing to m minus 3 to the 1/2 power, which is 3. I. C to the 2/3, or 2 to the 2/3, letter C, would be the 3rd root of 2 squared. What is 2 squared? 4, which is V, number 5. D, m to the 1/2 minus 3 is 1, or I. 2 to the 1/2 is the same thing as the square root of 2, which is IV, or 4. And then F is 3m to the 1/2 power, which is 2. I'm going to show you the way to not do it. And then I'll show you the way to do it. Okay. So we're going to use our calculator for this first part. We are going to estimate. In a lot of cases, estimating is fine. But for this case, we do not want to estimate because we want to be able to get exact answers. So we're going to practice what not to do first. So what not to do. Square root of 5. We're going to estimate that. So use your calculator. If you don't know where the square root button is on this white calculator, you type in the 5 and you hit shift, and then it's the top button 3rd from the left. It's going to be like 2.24 is what I will estimate it as.
2.24.
So type in a 5. You hit shift, and then the 3rd button from the left at the top row. Yeah. Okay. And then if we did the square root of 2 estimated, we would get 1.41. And then if we added those together, 2.24 plus 1.41 is 3.65. So if we made a number line, about where would that 3.65 go on that number line? Go ahead, Zion.
In the middle of the 3 and the 4, but like just a tad bit closer.
Yeah, pretty much in the middle of 3 and 4, but if I can make it a little closer to the 4, I would do that. But again, we're not being exact here because we're estimating. What do you notice about that second problem?
As fraction.
It does. Anything else?
It's the square root.
Yeah, it's the same thing as the first problem. 5 to the 1/2 and 2 to the 1/2 is the square root of 5 plus the square root of 2, which is what we just did. So we are going to write the same thing. 1, 2, 3, 4, 5, 6. We already know it's about 3.65. So we're going to put that point in the middle of 3 and 4, a little bit closer to 4. So let's try the next one. Square root of 5 plus square root of 5 is 2.24 plus 2.24. I'm getting those because we already did that. 2.24 plus 2.24 would be 4.48. Where on a number line would 4 and 48/100ths or 4.48 go? Yeah, Thorne? Practically in the middle of 4 and 5. The slightest bit closer to 4 than 5, but for our purposes, it would be closer, or pretty much in the middle. What do you notice about that fourth one? It's the same thing. This means the square root of 5 plus the square root of 5, which again is about 4.48. So 1, 2, 3, 4, 5, 6, again in the middle of 4 and 5. We're not even going to do that last one. The reason why is this is what we are not doing. We are not getting decimal approximations because we want to be exact. So what we can do is we have a different strategy of how to add or subtract things that have radicals. So if we look at A, it says the square root of 12 plus the square root of 3. We can't add those right now because you can only add things that have the exact same number under the radical. Just like terms, if they both have to have just an x to be able to add them or have an x squared to be able to add them. But we can do something. I want you to think back to Friday. I want to simplify the square root of 12. So can you think of a perfect square that divides evenly into 12? So let's think about the factors of 12. 1, 2, 3, 4, 6, and 12. Or any of those perfect squares. 4. So we could change 12 to 4 times 3. And then if we take the square root of 4, we would end up with 2 square root of 3. We remember doing this on Friday, right? Okay. So now I'm going to change the square root of 12 to 2 square root of 3. Now I have a question. Do they now have the same number underneath the square root? Yeah, they both have a 3. So we're allowed to add them together. We're going to add together whatever number's in front of the square root symbol. This is a 2. What number's in front of the other square root symbol?
0.
A 1. Miss Simpkins, there's no 1 there. Yes, there is. It's imaginary, so we're going to write it in there. 2 plus 1 would give us 3, and then we do not change what's underneath that square root symbol. We leave it as 3 square root of 3.
Wait,
What do you notice about letter B?
it's
It's the same thing. So we don't even need to go through all that nonsense. All we need to do is rewrite this using an exponent. So we're going to have a 3. And then our second 3 is going to be to the 1/2 power. I'm changing that square root into an exponent of 1/2. I know. It'll be all right. If we initially look at letter C, I have a 72, a 15, and an 18. None of those are alike. But let's work piece by piece. So 72. What is and be careful here, the largest, because there's more than one perfect square that divides into 72. Zion. 36 is correct. So we can make 72 into 36 times what other number? 2. And if we take the square root of 36, that is 6. And we're going to leave the square root of 2 the same. What about 15? What about 15? There isn't, yeah, you're right. There isn't a perfect, besides 1, but that doesn't really help us a whole lot. So we're just going to leave 15 by itself. And then last piece is 18. 9 is the biggest perfect square times what? 2. And if we take the square root of 9, we would get 3. So those 3 pieces is everything I can simplify. Now look at it. Do you see anything that's like that we can add together? Yeah. The square root of twos. I can add 6 and 3 together to get 9. Square root of 2. And then we still have to have that square root of 15 left at the end. And that would be your answer. What do you notice about letter D? Exactly the same thing. So let's just rewrite our answer using those exponents. So you have 9 and then 2 to the 1/2 plus 15 to the 1/2. Yay. How's your brain? Is it okay? Eh?
He's bold.
Okay. You're gonna love E and F. And I'm not saying that sarcastically. What do you see on E?
32.
Well, besides that. There's a square root and a cube root. Since they are different roots, we can't do anything.
Oh, so
Different roots.
different rules.
So they are not like terms. And we can't even make them into like terms like we have been doing on A and C because they're a square root and a cube root. We're stuck. We can't do anything else. Okay.
So that'll be a question.
I haven't even made the test. Sure. Sounds good.
Wait, that doesn't need to be tested.
Huh?
Doesn't need to be tested.
Okay. All right. So what I would like you to do, listen carefully so you don't do anything extra. I only would like you to do on the try it, A and C, because B and D are the same thing. Just rewrite it using that exponent. So I want you to try A and C. Okay. Okay, so on letter A, do they have the same number underneath the radical?
Yes.
So that means we're allowed to add them. So there is an imaginary 1 in front of this first one. So 1 plus 3 would be 4 square root of 6 or 4 root 6. Okay. Letter C, right now we can't add square root of 50, 18, and 10, but we can try and simplify. 50 is 25 times 2, which the square root of 25 would be 5 square root of 2. 18 can simplify into 9, and then the square root of 2. So that would be 3 square root of 2. And then 10 you cannot do anything with because the factors of 10 are 1, 2, 5, and 10. And none of those are perfect squares. So then we can just add the 5 and the 3 to get 8 square root of 2, and then the square root of 10. Okay, quickly, B and D. B should have been 4 and then 6 to the 1/2. And then D would have been 8 times 2 to the 1/2 plus 10 to the 1/2. Yay. Okay, I am going to skip the beat the test for now because I want to make sure that we talk about multiplying before y'all leave today. And I want to try my best to finish at 3:40. So let's jump to just the next section. I'll come back to the beat the test if we have time. So we talked about adding and subtracting. They got to be like terms. They have to have the same number under the radical, and the same root. So they can't be a square root and a third root and be able to add them or subtract them. Multiplying and dividing is a whole different ballgame. We are allowed to multiply and divide anything we want to. So the square root of 10 times the square root of 2. Well, what's 10 times 2? Square root of 20.
Okay. This is
But
easy.
But if you can simplify it, I would like you to. So can we simplify the square root of 20? Is there a perfect square that goes into 20? Zion. 4. Square root of 4
It's 2.
times the square root of 5 would leave us with 2 square root of 5. And just like before, same thing for the one next to it. We would just write it with its exponent would be 2 and then 5 to the 1/2 power. Good so far. Okay. Notice how these are different roots.
So can you not? You can't.
We can multiply them. We just have to use the exponent version. And let me explain how we're going to do that. Think about this. If you have x squared times x to the 6th, what do you do to those exponents? You add them. We're going to do the same thing. The things we're adding just happen to be fractions. So 1/2 plus 1/3. Those are the two fractions on those bases, right? And they got those because our original problem was the square root of 2, which the square root of 2 is equal to 2 to the 1/2. The third root of 2 is equal to 2 to the 1/3. So let's go ahead and add those fractions. What do we need when we add fractions? Same denominators. In this case, the most simple denominator would be 6. It would be 3/6. 1/2 would become 3/6. 1/3 would become 2/6. I can never say that right. 6ths. If I add the numerators together, I would get 5/6. So when we write our answer, the base doesn't change. It's still 2 to the 5/6 power. How could I write that as a radical? Go ahead.
Would it be the radical symbol with the 6 on the outside, and then 2 to the 5?
Right. So our 6 is our root, so that's why it goes outside the radical, and then 2 to the 5th power. And I'm going to be mean to you. I would like you to simplify 2 to the 5th power. 2 to the 5th power means 2 times 2 times 2 times 2 times 2. 32. So our final answer for the radical version, because we can simplify as much as we can, is the 6th root of 32. That's how you would read that. The 6th root of 32. We can also divide. What is 10 divided by 2? Square root of 5. Can I simplify 5 at all?
No.
I can't. It is as simple as I can get it. We can write it as 5 to the 1/2 power. Good. Woohoo! They're not laughing at me. That's okay. Okay, we have a few more, and then I'll promise I'll be done torturing you. Let's look at the let's practice. We're gonna look at a few of them. So letter A, x to the 1/3 to the 1/2. So I have an exponent to an exponent. I don't care that they're fractions. What do I do when I have an exponent and another exponent? Multiply them. Multiply them. So we want to multiply 1/3 times 1/2. So we multiply the numerators. 1 times 1 is 1. And the denominators, 2 times 3 would be 6. X to the 1/6. Letter B, I would suggest first changing that square root to an exponent. So the square root of 7, I could rewrite as 7 to the 1/2 And that is raised to the third power. Well, what is 1/2 times 3? 3/2. Leave it as an improper fraction. 3/2. Again, I just multiplied 1/2 times 3/1. 1 times 3 is 3, 2 times 1 would be 2. Okay, don't freak out. Letter C. Just look at the A's. What are the two exponents on our A? 1/2 and 2/3. Since I'm multiplying them, I want to add 1/2 and 2/3. For the B's, I'm going to be adding 2/5 and 1/2. I'll give you a moment. This will be the last one we do. There's 2 other things I'm gonna have you write, but not the problems on here. This will. What's the common denominator of 2 and 3? 6. So 1/2 should be 3/6. 2/3 should be 4/6. So that would be A to the 7/6 if we add those numerators. And then B's, the common denominator of 5 and 2 is 10. So that would be 4/10 and 5/10 would be B to the 9/10. I didn't ask you to do this, but if you were asked to write that in radical form, the A would be the 6th root of A to the 7th power. And the B would be the 10th root of B to the 9th power. Again, I didn't ask you to do that. I just want to make sure that that's a little bit familiar. Okay. Okay. 2 things I do want to note because I didn't realize that I asked these questions on the homework. And when second period, I gave them, or what's today? Teal day. First period. I gave them some time to work on their homework. So I wanted to make sure I touched on these 2 things because these were like the most common questions that I got. So if you see something as follows, I might write this down because it is very similar to a problem you will see on the homework. That's not what I wanted to do. Go away. If I had the 6th root of x to the 3/4 power, the first thing that I would do is rewrite that 6th root as an exponent. So we're going to keep x to the 3/4. And what would the 6th root look like as an exponent? What fraction? 1/6. So now that it's written as 1/6, what can we do to those exponents? Multiply them. 3 times 1 would be 3. 4 times 6 would be 24. You could leave it like that. Or you could notice that 3/24 is also the same thing as 1/8. I don't care. I will take both. So if you don't want to simplify, doesn't matter to me. Okay. The other thing that I just wanted to touch on really quickly is if we're multiplying, you are going to multiply the outsides, 2 times 5, 10, and then multiply the insides, 10 times 3, 30. Okay, I should make that clear. All right. All right. That's all I have today. Y'all may go if you want, if you don't have any questions. Okay, which part, Jonathan? I want to unconfusion. Unconfusion, that's not a word. I'm just tired, Renee, I'll be honest. I didn't get a lot of sleep last night. So this part. Okay, are you okay with this bottom piece? Okay, so let me start over. So hold on. Okay, so there is a question similar, and I'll even use the question that's from the homework. Hold on, let me pull it up. The question from the homework says the 8th root of 5 to the 2/3 power. Okay, and I want you to oh no, put it on my desk so I can wipe it down. And I'm asking you to simplify that. Right now, we can't simplify things that are mixed. This has a radical and an exponent. So we need to change it. We can change this radical, so we still have 5 to the 2/3. How could you write an 8th root as an exponent? What fraction would 8th root be as an exponent?
Let's go to the darkest one so I can pick one out to do some more.
It wouldn't be to the 8th, it would be to the 1/8. Remember that root needs to go in our denominator of our fraction, okay? And then because we have an exponent touching another exponent, we can multiply them together. So when we multiply fractions, we multiply the numerators. So 2 times 1 would be 2. And then we can also multiply the denominators. 3 times 8 would be 24. Yeah, 2/24. And honestly, I'm not a stickler for that. If you want to leave it as 2/24, you can. You don't have to